So in this session, Lauri is going to show us a little bit about the demo model. Uh, if you reached this part, you probably have gone through the installation and you should be seeing now the software as it is shown in Lauri's screen. Um, and now the next step would be to open the demo model in Fluidit Water. And because this model will be used in the next tutorials as well. So it's a good model to start with.
Great. The way to open up once you have installed the exe version of Fluidit Water or any of the Fluidit software, you can find the demo model under the tools section here at the top. From there, you can then go to the open demo model and click on the demo water. Once you've clicked that, of course, the demo model appears. And it's good to remember that the software is a GIS software. So if you have a mouse, it really benefits you a lot to be able to use the middle wheel so that you can zoom in, zoom out. And by clicking it down, you can then pan around. There are some other tools that you can utilize for just the basic user interface viewing, but I do recommend using a mouse. And what you are seeing here are, of course, by default, we are visualizing all of the different components here in the demo model. So the lines are pipes and the dots, some of them are junctions, such as these black dots. Then we have consumers, which we have plenty in the system. Also, these big red dots are consumers. Then we have a water tank, so a water tower in this case. It also has a name, and in the demo model we do have descriptions of many of the components. So when you click on a very important component, you will be able to read the description of this specific component and what it truly is. Other components that are in the model, we do have if we start from the water source itself, we do have a reservoir, which is now in the modeling, in hydraulic modeling, it is an unlimited source of water, or then alternatively, it is you can put as much water there as you possibly can. But in this case, it is a source of water, and as you can see, it is then going from there into our main pumping station, where if you zoom in, you are able to see the main pumping station. And here we have a type, so it is keeping a constant outlet pressure at 64 meters at this point. So it is pumping the water into the water tower and into the system. Also here we have another pumping station, which is keeping the pressure to this small zone over here. One way to visualize different zones is to right-click on any point in the model and going through select and select components in zone. And this will allow you to get an immediate selection of all those components that are part of this one pressure zone. Alternatively, if I would do it for the water tower, I would be able to then immediately get an understanding of the extent of the water tower pressure zone. And as you can see, here we also have one other pressure zone, which is behind a valve. And now, of course, a valve is something that is capable of maintaining a certain pressure or putting a certain amount of flow through it, but it is not capable of increasing the pressure in normal cases, in reality. In the modeling, there is a way to do this, but basically how you would use a valve would be a flow control or pressure reducing. Those are the most two common ways of utilizing a valve. And so now, for example, it is a pressure reducing valve, and it is keeping a setting of 25.5 meters. And if you want to, obviously now that we have seen the model and the extents and different components, which you could add your own here, perhaps we will go later to that. But for now, understanding results would be the first thing that you would like to do. And for that, it is possible to, using this selection tool that is by default your mouse option, you can click on any component, as I've already done, and it will select that specific component. And then in the results section, you are able to see all the different results that are available for that specific component. But this is not the best way to view results, as in a water network, we are always having fluctuations. We're always having different level of the water tower and different flows depending on the consumer behavior. So we really want to understand the changes in different results throughout the day. And for this, I would recommend utilizing a results window, which you can open up different types of new windows under the window section here. If you click on the results window, it will open up here next to your map view window, and by left clicking on that, you're able to then drag it somewhere else. And you're able to see this orange screen, which implicates that where would I, if I drop it here, it will then take up this space. Generally, the results windows are quite small. I don't want to be taking up too much space of the total window with that. So I will just put it, for example, here at the bottom. And how to utilize that more is that you have to then select a specific result that you want to utilize here. So, for example, here I would like to select the pressure result. Once I have selected a result, I can click on any component in my network, and if it has that specific result, it will then show it. So in this case, for example, for a water tower, the pressure of a water tower is basically its level. So here we can see the water level meters in the storage tank that it has water in it. If I click on any other component, for example, some of the junctions, then I will be able to see the pressure at that point in the network. And if you remember, for example, the valve was keeping a constant pressure of 25.5 meters, and that is now represented at the downstream of this valve. So it is 25.5 meters. But once the flow starts going through here, it starts to have some variation later on because of these consumers are behaving in a certain pattern, according to a certain pattern. And that's actually really interesting, is to get an understanding of the consumer behavior. And I think for that, we could go next, is to click on a single demand. And for that demand's properties, we can see the daily demand, which is now in this case, it is cubic meters per day. And then here we have a pattern that this specific demand is utilizing. There are certain ways we can, for example, open up this pattern list, and we can click the control button down, and this will allow us to visualize, have a quick look at this type of pattern. So for example, the peak household tells us that we are having very little water usage in the night. And then once people are waking up in the morning, of course, there is a peak in the usage. And then in the evening, there is the highest peak in the consumption. And so what the pattern means is that the base demand, which is daily demand divided into liters per second throughout the whole day, is then all the time multiplied by this for every different hour of the day. So a pattern generally represents one whole day of behavior. If we have a look at a few of the other patterns that we have a moderate household. So this does not have such a big peak, for example, in the evening. And then we have a 16-hour factory work. So in this case, it could be some type of factory or shop or something that opens up at a certain hour, and then it is more or less constant, the water usage, until it ends, and there is absolutely no water usage in the night at all. And so utilizing these patterns, it creates the variation in the flows, and of course then in the pressure. We could open up another result window, as you can have an unlimited amount of these result windows open. And we could click here and you can write if you want, and we could look at the absolute flow result. And this would allow us to then understand the flows throughout certain segments of the system. You can also select many different components, and both of those results will be shown. It's also good to remember, now that I have selected pipes, I am not getting any pressure results, because pipes or links, as they are known in hydraulic modeling, they do not have pressure results. Only dot type of node results or node components have pressure results. But the same applies then vice versa to flow. So if I select different node components, I can get their pressure results or some other node specific results, but I will not be able to see any flow because they do not have flow.
Lauri, thanks. That's really nice to clarify. Just a question for someone that's starting to use Fluidit. How do you check what type of results certain component has?
Yes, well, as was shown a little bit earlier, that you can always go, once you select a certain type of component, you can go in here in the properties window that is by default open there. You might sometimes accidentally hide it, for example, but it is still open up there, and you can just open it up then. And now, for example, I have a junction selected, so I could go into the results section of the junction. And here I will be able to see all the different types of results that are available for this specific type of component. Some of them are zero, and some of them are not calculated because they are used only in certain analysis that can be calculated and utilized through here under the tools. But for most of these generic results, such as demand and head and pressure and leak, are always calculated in the simulation. If I would alternatively go to a pipe and get an understanding of its results, well then of course I have the absolute flow and head loss and hydraulic power and length related results and velocity and unit head loss, which are of course a very important factor in understanding all pipe flows and network functions.
Thanks, Lauri. Just another thing that I am curious about is also the symbols that we have, like what we are seeing on the map. If you could, for a moment, just turn off the visualizer that has the symbols, just so we see it in a little bit different way. It might be more familiar.
Great point. Yeah, let's do that. So, and also let's talk a little bit about the drawing states. So here, as we have now been clicking on individual components to get an understanding of their specific results, we also want to get an understanding of the whole network's results. And for that, we utilize the drawing states, which are seen here. And in the demo model, we have quite a few different drawing states available. It's also good to remember that you can, if you create a new model, you can always take through the file and import features from model. You can take your drawing states, for example, from the demo model, or then alternatively, under the tools, you can open up the predefined drawing states to get immediate drawing states to benefit from. You don't have to create them yourself, which is also possible by right-clicking on the drawing states and then creating completely new, fresh one that you can fully select everything that you see there. But what are the drawing states then? Well, in this case, the default visualization is showing all the different components that we just have in the model. If I click on the arrow here, I'm able to go under it to get a understanding of all the different things that are shown here. If I would double click or right click and change visibility, in this case I will double click it, I would then deselect the visualization of the junctions in the model. And now I'm not able to see them, and I also can't click on them. So you always want to have the type of components showing there that you are interested in at a specific time, depending on what you are looking at. And now, as was asked, I could deselect the symbols. And if I do that by double clicking, then all of the components will refer to their basic state. And so now we can actually get a bit of an understanding. So all the components that are in the model are more or less as is shown here in the component creation tab. So for example, the water tower is now looking as such, and it is this component here. But as we have selected a specific symbol for this, we have plenty of possible default options. You're also able to bring your own symbols for any components that you desire. But as it has, we have selected a tank symbol for it. So once I do have the symbols open, it is visualized with a little bit nicer symbol. And also here we do have another tank, which is water intake tank in our main, source of the system. And we also have some symbols such as this main pumping station. And also here we have a kind of pumping symbol. And in here we have a station or equipment symbol that is being utilized. And that becomes extremely useful the bigger models you have, so that anyone can immediately get an understanding of the most interesting points, the most important points in your system by just seeing different symbols throughout. In this demo model, as we have a very small network, they are not necessarily that important. Again, if we deselect that, now we wouldn't be able to really get as much information out immediately. But it is always good to refer back to the basics and get an understanding of that those different symbols that you see in the network, they are just basic components that have been selected to visualize an interesting point in the network.
Okay,
If I
thanks,
now go
Lauri.
just to, yep,
Sorry
go
to
ahead.
interrupt you. Just a comment that if someone that is watching us now, if they are accustomed, if they are used to EPANET, then the basic symbols they might be easier to understand at first. And as Lauri said, you can bring your own symbols or use the ones that we have by default there and choose accordingly. But if you're starting with and you're used to EPANET, then you can just turn off the symbols and then you will understand a bit easier from the start. Sorry to interrupt. Please continue, Lauri. Thanks.
Point. Yeah. So that is good. And whenever you are creating anything new in the model, it is by default the EPANET symbols. And so if you would be bringing in through the import components from file function, or then creating your components by hand in the model, it is the basic EPANET symbols. But in this demo model, to make it a bit prettier, there are some symbols utilized. Just wanted to, now that we had a little look at the drawing states, it's a really important part of utilizing the Fluidit software. So let's have a look at a few of more of these. For example, just under the default visualization, we have the pipe sizes. So in here, we do have a description again of this specific drawing state, which is visualization with no maps in the background. Well, actually, it does have in the background. Visualizing pipe sizes and size labels. And so here we do have possibility now to zoom in, and then we get to see what is for each of the pipes their material being used. If I select a pipe, I will be able to see the material of the individual pipe also in here. And where the material comes from, it is coming from the material library. This is by default opened up in the demo model. You can also open up under the tools in the new model. You can open up predefined material pack, or you can import your own materials from, for example, from Excel, that you might have a library there. But so PVC pipes and pipes, so plastic pipes we have in the system. And all of the diameter and roughness and other parameters are then brought in from the material library. So it reduces a lot of implementing, putting manual work for the pipes, as you can just refer to a certain material being used there. If we look at some other drawing states, we have maximum head. Let's zoom out a little bit to get a view of this. So what we're now showing is the maximum head in the system that happens at any point throughout the day, and this is meters above sea level. So here we are actually in the demo model is based in the city of Helsinki, and this is at the sea level where we are taking the water now. And so here our pumping station is relatively at sea level. But then once we go pumping it more into the system, we have more head over here. If we look at the average pressures, then we get to see, well, as the name implies, the average pressures throughout. And of course, as I mentioned, the pressure is changing throughout the day. But for example, now we are showing the average result. So 46, of course, now it is rounded up to the closest full number. So it is 46 value in here. But the maximum pressure would be a bit above 46, as we can see it's 46.6. And then the minimum pressure would be 44.6-ish. If we have a look at some of the other drawing states, we have minimum and maximum pressures. And in this, it is quite interesting as we are utilizing a background layer. All of these different drawing states have some specific background layers open there. And for example, in this case, we have an elevation layer, which is now showing the elevation above sea level in this color scheme. We could change this also from model and edit result colors and sizes. Depending on where you are geographically, the meters above sea level can be quite drastically different, of course. But what we're seeing here, for example, is the minimum pressures and maximum pressures in the system. There are different ways to utilize these visualizations. They can also be changed always, and a lot of things can be done on the visualization.
I've raised my hand here. So now that you're showing the background layer, that's really interesting. Can you also show in the profile view, this longitudinal view?
Yeah, as we have opened up a few different windows, the same place we could utilize under the window, we have the possibility of opening up different windows, and in here we have the profile view window. Again, dragging that somewhere, for example, to the bottom is a neat place for that. And how to utilize that then is that we could select, for example, the reservoir, and with the control button down, we select another point in the system. In this case, I will select the water tower. And so now I have two node components selected. I can just right click on anywhere in the map view window and find the best route or the shortest route. In this case, it is the same because there is only more or less one way for the water to flow. And what we see here, if you lock the selection, then we will always be keeping this specific profile view open here. And so that is now a good thing that I want to do here. What we're seeing in the profile is that we are around the sea level, so 0. And then the pump, well, that's interesting. The pump is increasing the pressure to that amount so that the water now can flow in, as we can see here, the flow in this pipe through the pump that has pumped it to this pipe is now going to the water tower, which is at this elevation here. If we also would want to get the actual elevation resolution of the ground elevation, we could select here on the profiles properties some elevation resolution. And then it is showing the actual ground elevation in this case. That is the green line now represented on the profile. Where this data is coming, it is coming from the Digital Elevation Model Manager. I take the elevation resolution away, then the black lines that I'm seeing are now representing the one point from one junction to the next junction, to the next junction, to the next, and so on. And so they are straight lines in the model, in the profile here.
Yes, I have always some question here. So the background layers, it's really interesting. I can see that some parts in the model are a bit higher than others, for example, close to the water tower. Could you show in the Bing map or right click and show some view of the area itself, so someone that is opening the model for the first time, they can actually see in reality how that would look like?
Great, let's do that. So, utilizing more on the background layers, you have the possibility of right-clicking, of adding up more different background layers. If I would want to, I could, for example, add a Bing aerial map. And here it opens up now the aerial map at the top of the background layers. And this is now an important topic as we do still utilize the elevation layer, but it is under the Bing aerial map. So the aerial map is now drawn on top of it. And so we don't actually get to see the elevation layer. What could be done here is to left click on the aerial map, and I can then drag that, for example, below the elevation layer. And that will now mean that the aerial map is drawn first and the elevation layer is drawn on top of that. If you have many different layers and different background maps open, it can slow down a little bit. So you might not want to keep unlimited amount of different layers open there. The color layer can be utilized though, as you can open that up and bring it, for example, on top of the Bing aerial, and now it is drastically changing the view here. If we change the opacity, then we are able to kind of adjust of what we are really seeing in the system on the map view window. And you could also, if you would want to, you could right click on any place where you have your pipes. Here on the streets, you could right click and then GIS operations. You have the possibility of going to Google Street View of that location or the closest that is available, or a Bing Bird Eye View. And this will then allow you to get a immediate understanding on your browser, web browser, that will open up once you click these. So there are different ways to utilize the GIS options that are available in the software.
Thanks, Lauri. uh, I often get also a question, or I myself would like to know, for example, about the demands in this demo model. How much water is consumed by the whole system, for example. Is there a quick way to check that?
Great question. So to get an understanding of your network consumption, there are a few different ways. Of course, now as we know that all the water is coming through this one pipe, we could just get an understanding of the total amount of water that is consumed is if we utilize a gross flow result. By clicking on the pump, for example, we are able to see that it is pumping 814 cubic meters per day into the system. So that is the total amount of water in day that is being consumed there. But we do have then also possibilities that are a bit more advanced. We could utilize also, well, for example, under the tools, and then demands, and we could assign leaks. So we can actually get to understand the whole system, for example. We can click on assign here, which will cause that it will then calculate the results of all of the different sections. And so here we can get an understanding of the whole system. What is the pipe length, the average diameter of the pipes, revenue water, which is meaning that it is water that has, in this case, it has some type of pattern implemented to it. And so it is considered billable water, revenue water. But then we also have some non-revenue water that has been implemented. So that would be generally leaks, but also other type of water usage that cannot be billed. And in total, we can see that the whole system, the calculated water flows is around 817. Now this gives us an understanding of, we also can utilize the different zones that are in the model to get an understanding of how the water usage is divided between them. If I would go here, I believe pressure zones drawing state. Now this would then tell me that, oh right, I have a lower zone here, I have the main zone, I have an upper zone, and well, this is the raw water that is over here.
Thanks, Lali. That's very interesting and easy to do to check those important results. Um, One thing also that I believe everyone that opens this model for the first time would be curious is about the scenarios. So if you could, I don't think we will have time to go through all of them, but if you could just mention what each of the scenarios does, what is the idea behind it, then later on someone opening it can, of course, explore it by themselves.
Great point. Let's do that. I will just close, for example, the background layers so I'm not having so cramped up the model browser here. So by default, when you're opening the demo model, the base scenario is opened. And this is that shown as it is bold, written in this case. And also at the top, you're always able to see the scenario that is now opened. If you then double click on another scenario, for example, the peak day, if, for example, I would have some results showing here, for example, the velocity in the system, and I will now double click on the peak day, it will then load up the results of this peak day. And again, here is a description, so you can get more information on what this specific scenario is really all about. In this case, for example, the demand multiplier or all of the consumption is changed, so we have a lot more water flowing into the system. Now, if I click new pipe and consumer, well, in this scenario, we actually have a new pipe section and a consumer then there at the end that is consuming water. In this scenario hydrant example, we have utilized a hydrant component, and that is simulating the water intake at a hydrant or a sprinkler. And there are also some automated tools that you can utilize to get a whole understanding of your whole network, again found under tools and analysis. But in this case, we have just a simple hydrant component that is taking water at 2 hours, and so you have the possibility to get an understanding of the behavior of the network. Under this, we have even more child scenarios where some specific amount of water is being taken to the hydrant. In this scenario, controls with Python is actually a good place to go back to the base scenario and understand the difference, what is now the controls with control stations and what is then possible in EPANET. So as you might be familiar with EPANET, the rules and controls is the way to deal with the possible automation in your system. And those are also available if you click on the scenario, left click, and you are able to see the properties of the scenario. And in here, you're able to see that we do have some specific rules in place. And these, of course, come from the EPANET style. So rule 1, if system clock time is 6 a.m., then pump pressure booster 1 is setting is 35. And if system clock time is 10, then the pump pressure booster 1 setting is 30. And so what I did here now is I selected the name of this pump because I want to know where is it. And I will just click then cancel. I want to get an understanding of what does this setting do here. I can control F on my keyboard and it will open up the search field, as is most common in most softwares. And if I now just copy here the name that I copied from that rule and click OK, it will then select that specific component which has the name pressure booster 1. So the constant outlet pressure of setting 40 that it is trying to keep, but the rules are now overriding this type of setting. And if we click on the pressure shown here at the junction where it is pumping, we're able to understand the fluctuation through the day that what the rules are applying here. So we are changing the pressure that the pump is maintaining in this pressure zone. And that is of course the traditional Eponet way. But what is possible in Fluidit is then to create with control stations some more advanced automations. This can be found under the model and control stations. And in this specific scenario, the controls with Python, we actually have now implemented a couple of different controls that override the component's own system and settings. So for example, booster 1, so it finds that component in the model, and then the setting of it is being changed according to the parameters given here. As you can see, it is now familiar to the rules that was given earlier in the Eponet way. But for example, here in the main source of where the water is being pumped, we have the possibility of then giving a lot more advanced ways of giving automation to components so that we can truly model the system one-to-one with reality, which is generally not possible to do with the Eponet rules and controls. And so in this case, the controls with Python changes, especially the way that we are pumping water into the system in this case. So the flow through the main pump is very different in the base scenario and then in the controls with Python because of the change that we are now defining it more accurately in accordance to the water tower level. In the demo model, you can have a more peek at that specific control. And what we then have is we have a larger model. And so if I would double click on that, it opens up a whole new world. And in this case, we have now two reservoirs. We have two water sources. So the same one that we had here, the reservoir 1, and then also we do have another reservoir 2, a different water source. How to advance and get an understanding on this case, we could utilize the advanced drawing states. For example, double-clicking on the water source. So you open up the advanced drawing states and double-clicking on the water source. It will then give an understanding of the spread of water from the different water sources in this network. So as you can see, the reservoir 1, which is now defined in red, it is mostly spreading into the system, and the reservoir 2 is helping somewhat locally, but some of that water is also spreading into the southern part and also to the northern part of the system. Other type of results that could be interesting the more bigger your network becomes is, for example, the water age, is to understand how old water do you have in your system at certain places. Under the larger model, then you even have another type of peak day result. But if you want to create your own child scenario, you can select on the specific scenario that you want to create it, and with the right click, create child scenario, then you are able to create a new type. As I click now for the peak day, that's actually not a good place to create. Let's create it for the larger model. A new pipe. And if I go into that specific scenario, I don't have any results yet because this is a fresh scenario and it hasn't been simulated. So I would have to go to simulate, or then click F5. And now that it was simulated, I actually have results in this scenario, and I could now utilize this to make any changes. So for example, I could create a new pipe section by clicking on the pipe over here, the pipe creation tool, and clicking the control button down. I'm able to create junctions as I'm left clicking away. And by then clicking the ESC button, you will stop creating new pipes and you will go back into the selection tool. By default, the new pipes that you have created do not have a material. You could select that material for them that have been just created, or in the beginning you could have selected what type of material is being done immediately. But for now, I don't care about their material. I just want to simulate this again, because whatever change you ever make in a scenario, you always have to simulate it after that to have results in those components. And that's always important to remember, that you always have to simulate to get an understanding of the changes you made. So I will click F5, and now the new pipe here, I would be able to understand the pressures of that. And I could, for example, take the profile from my reservoir 2 and control button down, selecting this, and find the best route between these 2 points. It would be able to then find the route from the reservoir to the point that I just created. And of course, if I go to the larger model, you will be able to see that this scenario doesn't have the change that I just made in the new pipe. So the scenarios are hierarchical, and whatever change you make in a parent scenario, that change will come down to its children. Whatever change you create in a child scenario, it's not gonna go upwards in the tree-like scenario structure.
Thanks, Lauri. That's very nice overview of the scenarios, and also a nice instruction how to create your own scenario and start exploring. But if I would like to just go some steps back here, if we could go again to the base scenario, and from there show a little bit of the pumps that we have there, because we have pump battery. So someone that is used to EPANET, they might find this component specifically a bit different than EPANET. Could you talk a little bit about that?
Great point. Indeed. Most of the components are one-to-one to EPANET, as they come from there. But the pump battery is a Fluidit component, so to speak. The normal pump, which is exactly the same as is in EPANET, will require you to have a pump curve, and it will then be driving on that specific curve that you have implemented, depending on the system curve, and of course, whatever flow is needed, then it will create that pressure there. But the pump battery is a little bit different, as we've already had a bit of a look at that, is that you have the possibility to give it a way of functioning. So whether it is constant flow, constant outlet pressure, constant inlet pressure, or constant generated head. And it does not require you to have any curves there. So at the moment it does have, but if I would delete these, now this pump battery does not have any information of a curve or a what type of pump might be there in reality. It will just function as a way that is told that it should function. Of course, now it is being functioning in the way that is defined in the rules. But then if we do want to get more accurate electricity calculations, and also we want to just understand if we actually know the pump, we could add a certain pump for this pressure booster 1, for example. Here I do have one pump definition created in the model, and I can now click calculate, and it will then calculate according to this pump definition. By clicking show working range, I'm able to see one pump and its range, and now these black dots over here are representing the actual functioning of the pump throughout the whole day that we have simulated. So as we already had a look previously, it is functioning at 2 different pressures throughout the day, and actually in the higher pressure that it is pumping most of the day, it is working at a much better efficiency than the lower pressure that it is functioning at the night. We could then also get understanding of some other results that are now specific for this pump. For example, to get an understanding of the variable speed drive and how is it functioning at what frequency throughout the day. If the pump would be working somewhere outside of its curve, then what would be utilized for the electricity calculations are some default values that are defined over here in the model properties, where you can also change any other parameters such as time and units and others that you might be interested in.
Thanks, Lauri. That's very, very interesting. I think we are almost out of time. So, of course, we will, during the tutorials or other documentation, you will find more details on how to use each of the tools and also more details about the user interface, where to click, how to operate. Before we end this, could you just show perhaps just one schematics so we show this reporting capabilities that you have in the software?
And as you mentioned, the schematics is a really unparalleled way of reporting different things from your various scenarios, and then to copy those to your results, or to just have them there as a type of overview of your system. And so what do we mean by schematics? So as we've now already explored the drawing states, the background layers, and now the scenarios, the digital elevation model manager was mentioned slightly, and we have here the schematics. So in the demo model, if I open up that by clicking on the arrow, there are some ready-made schematics. If I double click on these, I will open them up. And these are now ready-made report style views of the model, whatever we have here. Let's have a look at a few of the others. Here is the overview. Let's open that there. So we can compare different results. If I would go, for example, the peak day, now what we're showing here is the scenario peak day, how is that functioning, and we are comparing that to the base scenario. So you can create many different types of graphs, figures, views, and get an immediate understanding of the variation of how your system is functioning in relation to each other. As with hydraulic modeling, you're always interested in what if scenarios and any changes and how they might affect your normal average everyday life. If we have a look at just a few of the others, we have a water tower schematic, some more closer look on that. If we would be changing the time throughout, it would be now changing the water tower level. Pump analysis, you can create such views to get an understanding and compare different types of pumps on whenever you need to renovate, for example, or create new areas to really have your pumps sized properly so that they are energy efficient, but always matching the required pressure and flow that is still needed in the system. Hydrant discharge, as was shown a little bit before, In the hydrant example, we have created this kind of how much flow can we get out from the hydrant, and how is the pressure dropping at the hydrant in relation to that. Of course, which is very important in all sprinkler and fire hydrant flow analysis. Some more advanced examples that you can get a look at. For example, we could bring in actual real historical data using the data sources as time series, and then we can use this time series for visualization purposes to get an understanding of how our network is functioning in relation to actual historical data. Now that goes into very advanced things, but it is something to consider and also have a look in the demo model to get some understanding of that topic. So the schematics are very much used in the, especially in the consulting work, where you need to create different reports, as anything that you have created here can be just selected individually or just Control A, and you can then copy this to PowerPoint or Word or wherever, so that you have an immediate way of getting data, visualizations, and those specific points that you're interested into your report.
Thanks, Lauri. Definitely during other tutorials and documentation, you learn more about the schematics, but of course, it's also in the demo model. So you can just click around and then see the properties of each component to understand it a bit more if you are interested about that. Uh, but thanks, Lauri. This was really nice overview. I also didn't know many of the things that you were showing today, so it was also very good for me, and I'm sure it will be very useful for our users. So thanks a lot, and have a nice week.
Very much.
Bye.
Bye bye.